Good morning, students. In last class, I was telling about nuclear fission. You learned about nuclear fission. What is nuclear fission and chain reaction? What are the two types of chain reaction? Just tell me what are the two types of chain reaction. One is controlled chain reaction and another one is uncontrolled chain reaction. Example for controlled chain reaction is nuclear reactor. So today I want to tell about nuclear reactor, right? So we shall discuss about nuclear reactor in today's class. Nuclear reactor. So what is a nuclear reactor? Nuclear reactor means it is a device in which fission process, nuclear fission process is carried out in a controlled manner to get nuclear power. So what is nuclear reactor? A device. It is a device in which fission is carried in controlled manner to get nuclear power. So see, nuclear reactor is a device in which fission process is carried out in controlled manner to get nuclear power. So here nuclear power is electric power. What is nuclear power? Electric power. So what is the use of nuclear reactor? By the nuclear reactor we can get unlimited supply of, we can get maximum supply of electric power. The current that we are using for our daily applications, for our daily life purpose, that comes from nuclear reactors. So here near to this place means here we are having nuclear reactor in Shakti Nagar thermal power plant. So here nuclear fission process is maintained at a constant level, that is controlled manner. So the concept of nuclear reactor, it was given by Enrico Fermi. First, the concept of nuclear reactor, it was given by Enrico Fermi, and in India, the concept of nuclear reactor, it was explained by Homi J. Baba, and he was the first person to construct a nuclear reactor in India. That the name of the nuclear reactor is Apsara. Apsara is the first Indian nuclear reactor. And next Dhruva, Cyrus, Kamini, Rohini, like that reactors are now working in India. So the first Indian nuclear reactor is Apsara, and it was built by Homi J. Baba, right? So here what is nuclear reactor? Now only you learn nuclear reactor means it is a device in which fission process is carried out in controlled manner to get electrical power, to generate electrical power. So now see, we shall see the diagram of nuclear power. Nuclear reactor, not nuclear power, nuclear reactor. You also draw this diagram with me. See, all of you draw this diagram. This is the nuclear core. Right. So see here I am drawing the control rods. One of the part of nuclear reactor. Control rods are the parts of nuclear reactor. Nuclear reactor. Yes, what are these called? These are called control rods. The name is control rods. Control rods. In shortcut, CR. CR. Right? And here fuel is placed. Fuel and moderators are placed in this arrangement. So see this is M moderator. M stands for moderator, and this is the fuel. The middle portion of this part is the fuel. Fuel. So here moderator M. M stands for moderator. F stands for fuel, nuclear fuel. Fuel are the fissile material. This is the fuel. See here, this is the diagram of nuclear reactor. Here, say first one, these are control rods. Control rods, and here this is the part which is named as FM. Here M means moderator. M stands for moderator. Yes, what is the meaning of M? Moderator. F stands for fissionable material. F is fissionable material. Fissionable material. F. Fissionable material. Next comes coolant system. Coolant. This is another part of the nuclear reactor, and here this whole part is heat exchanger. This whole part is heat exchanger. What is present here? Steam is present. Steam flows through here. So here once again cold water. Here is the cold water. So now let me tell about the construction of nuclear reactor. Here the main parts of the nuclear reactor are first one, fissionable material. This is the first part of fissionable material. This is the first part of nuclear reactor. Fissionable material means here what is the fuel used in the reactor, that is called fissionable material. The fuel that we are using in the reactor for generating electrical power, nuclear power, that is called fissionable material. Yes, what is the fissionable material? This is the fuel of the nuclear reactor. This is the fuel used in the nuclear reactor. Fuel used in nuclear reactor. This is called fissionable material. For example, what are the fuels used in nuclear reactor? Uranium 235, 92. This is one fuel. Thorium 238, 94. Plutonium 239, 94. Plutonium 240, 94. So yes, see here what are the different fissionable materials used in the nuclear reactor, or what are the fuels used in nuclear reactor. Fuels are uranium, thorium, plutonium. So uranium mass number 235, atomic number 92. Thorium mass number 238, atomic number 94. Here plutonium 239, 94. Plutonium 240, 94. So these are the different fissionable materials that are used in the nuclear reactor. So the second part is, see here the second part is moderator. I am writing the second part as moderator. Moderator M. See, first of all, to start nuclear fission process. To start nuclear fission process, here the neutrons that initiate fission process. First, one neutron that hits the uranium nucleus. N plus uranium 235 ಬರೀತೀವಿ ಎಕ್ಸಾಮ್ ಒಂದು ನ್ಯೂಟ್ರಾನ್ ಇನಿಷಿಯೇಟ್ ಮಾಡುತ್ತೆ. That neutron must be a slow moving neutron. And see, in one fission process, how many neutrons are released? 3 neutrons are released. In one fission process, 3 neutrons are released. Those 3 neutrons are of fast moving nature. Their speed is maximum. So, and if the neutrons are moving with high speed, they cannot give rise to further fission process. So fission will not take place if the neutrons are moving with higher speeds, if their energy, kinetic energy is maximum, or if they are of faster nature, then they cannot give rise to fission process. They cannot hit the nucleus, uranium nucleus, and the neutron will not succeed in breaking the nucleus into 2 smaller nuclei with the release of 3 neutrons and 200 mega electron volt of energy. So, say what must be the nature of the neutrons? Neutrons must be of slower speed. They must be of minimum speed. So, to slow down, what is the use of moderator? To slow down the fast moving neutron. To slow down, to slow down the fast moving neutrons. Fast moving neutron. To slow down the fast moving neutrons, here moderators are used. To slow down the fast moving neutrons, moderators are used. Yes, what is the function of moderators? To slow down the fast moving neutrons. So they decrease the kinetic energy of the neutrons. So you see, what must be the limited speed or limited kinetic energy of the neutron that is provided by the moderators. So what examples of moderators? Example of moderator is graphite, heavy water. These two are used as moderators in nuclear reactor. D2O, heavy water is D2. Here graphite, heavy water, these are used as moderators in a nuclear reactor. It's very important. Listen carefully. What is moderator and what is its function? Here moderator means these are the substances. These decrease the speed of fast moving neutrons. These slow down the neutrons. These are say helps for decreasing the kinetic energy of the neutrons, so that the neutrons can initiate fission process. So if the moderators are not present means then neutrons are of high speed and they cannot result in nuclear fission process. See here fuel is filled in this box in powder form. Here what is the fuel used? Uranium 235. As I told you in last class, that uranium is taken in the powder form and it is filled in this box, and say among the two sides of the fissionable material there are moderators. So moderator means graphite or heavy water. So they are used along with the fuel. So you can see these 3 parts are representing M. M means moderator, F means fissionable material, M means moderator, right? This is about moderator. So your example, you should remember the example. What are the examples for moderator? Example is graphite and heavy water. Function of moderator, this helps us to decrease the speed of a neutron. See, the third part of nuclear reactor is control rods. Here you can see these are the control rods. These two are the control rods. So what is the function of control rods? These control rods helps you to control the rate of fission process. So if you want to maintain here in a nuclear reactor, what is the principle of nuclear reactor? Nuclear reactor is it is maintained at a constant chain reaction, अथवा it is carried out in controlled fission chain reaction. So to have the controlled fission chain reaction, what should you do? In among the 3 neutrons, ಪ್ರತಿಯೊಂದು ಫಿಷನ್ ಪ್ರೋಸೆಸ್ ನಲ್ಲಿ 3 ನ್ಯೂಟ್ರಾನ್ಸ್ ಗಳು ಎಮಿಟ್ ಆಗ್ತವೆ. ಔಟ್ ಆಫ್ ದ 3 ನ್ಯೂಟ್ರಾನ್ಸ್ ಏನ್ ಮಾಡಬೇಕು ನೀವು 2 ನ್ಯೂಟ್ರಾನ್ಸ್ ನ ಇನ್ಆಕ್ಟಿವ್ ಮಾಡಬೇಕು. ಒಂದೇ ಒಂದು ನ್ಯೂಟ್ರಾನ್ ಮಾತ್ರ ನೆಕ್ಸ್ಟ್ ಪ್ರೋಸೆಸ್ ಗೆ ಹೋಗಬೇಕು. ಟು ಇನ್ಆಕ್ಟಿವ್ for inactive absorb ಮಾಡ್ಕೊಳ್ಳೋದು. So these are 2 neutrons, they are moving up and down. They are placed in between the fuel and moderator. So when the nuclear reactor starts working, they are moving up and down, up and down. So as a result of this, what is happening here? Here these control rods, they absorb excess neutrons. Out of 3 neutrons, if 3 neutrons are released, means they are absorbing 2 neutrons and allowing only 1 neutron for causing next fission process. If 4 neutrons are absorbed, 4 neutrons are released, means 3 neutrons are absorbed and only 1 neutron is left for further fission process. So here see, here what is the function of control rods? These helps us to control the rate of fission reaction, control the fission chain reaction, rate of fission chain reaction. It means by using control rods you can obtain a constant value of energy in nuclear reactor, because out of 3 neutrons, 2 neutrons are absorbed by the control rods. Absorbs. Even on the control rods, absorbs excess neutrons, and allows only 1 neutron. They are allowing how many neutrons? Only one neutrons to start fission process. So thereby a constant value of energy is obtained in each process. So as a result of this, you can get controlled fission chain reaction in a nuclear reactor. So what are the examples of control rods? Cadmium and boron rods. Cadmium and boron rods. So see here the example of control rods is cadmium and boron rods, right? So what is the third part here? Control rods. What is the meaning of control rods? These are the substances which can absorb excess neutrons and thereby control the rate of fission chain reaction, and they allow only limited number of neutrons to cause fission process, and thereby they are resulting, cadmium rods are resulting in the process of controlled fission chain reaction in a nuclear reactor. What are the examples of control rods? They are made up of cadmium or boron. So these are cadmium rods or boron metal rods. These are the control rods. See here the fourth part is coolant. This is the coolant. Here coolant means it is a cooling material. What is coolant? Coolant is a cooling material which helps to remove the heat produced in the core of the nucleus. This is core. This part is called core. This whole part is inner part of the reactor is called core. So here due to the continuous fission process, continuous fission chain reactions which are happening in the core, they result in heat energy. So a large amount of heat energy is liberated inside the core of the reactor. So see, to remove this heat energy, who is there? That is the coolant. So what is coolant? Cooling material. Coolant is a cooling material which removes the heat and transfers that heat energy to heat exchanger. So in this heat exchanger, here the heat of the core it converts to steam. Idu heat exchanger. Heat energy yaru remove ಮಾಡ್ತಾರ? Coolant system, cooling material remove ಮಾಡ್ತಾರೆ. It removes and shifts to heat exchanger, and in heat exchanger here this heat energy is converted into steam. Heat energy is converted into steam, and this steam is used for running the turbines of the generator. It is used for running or working of turbines of the generator, and thereby electrical power or nuclear power is obtained. So here say what is coolant? A cooling material. A cooling material which removes heat from the core of the reactor. Heat from the core of the reactor. A cooling material which removes heat from the core of the reactor. That is called coolant. So example of coolant. See here water. It may be water, CO2 or nitrogen. These are used as coolant in a nuclear reactor. So what is the function of coolant? Yes, anybody? Coolant, it is the system which acts as a cooling material. And what is the function here? Coolant removes heat energy released in the core of the nuclear reactor due to fission process taking place. So it removes this heat energy and transfers that heat energy to the heat exchanger. It is transferring this heat energy to the heat exchanger, and in heat exchanger what is happening here? In heat exchanger this heat energy is converted into steam, and this steam is used for further processing turbines or generators. So the steam is used for running of the turbines in AC generator, and thereby electrical power is generated. So see, if the steam is left unused, this is transferred once again to the core of the nuclear reactor in the form of cold water. Here the steam once again is left unused steam. It is say here there are some openings. Here there is one opening and here there is one opening. So it is for the flow of steam. So unused steam, it runs backward to nuclear reactor. Once again back to the nuclear reactor. When it comes out of the heat exchanger, it converts to cold water, and cold water is sent to the nuclear reactor for decreasing the heat. Once again, this cold water is sent for decreasing the heat released in the nuclear reactor. Right? So this is about the coolant, and the last part is protective shield. So here protective shield is the outer wall of the nuclear reactor. This is the outer wall of the nuclear reactor. See here, the outer wall of the nuclear reactor, it is actually a concrete wall. This is the concrete wall of maximum thickness. Here, what is protective shield? This is the wall made up of strong concrete material, and it is having maximum thickness. So why its thickness is made maximum means it must absorb the radiations which are emitted in the nuclear core material, in the nuclear core, due to the fission process. Definitely maximum amount of radiations are liberated, maximum amount of radiations are emitted in the core material, and these radiations may cause injuries to the people who are working around the nuclear reactor or in the reactor section. So to protect the people from the hazardous radiations, here this core is built with a thick concrete wall. That thick concrete wall is called protective shield. This is called protective shield. What is the use of protective shield? It helps for protecting. It protects the people from the dangerous radiations which are released in the fission process inside the nuclear reactor device. So it do not, if the wall is of maximum thickness, this will not allow the radiations to come out of the wall and cause injurious health issues to the persons who are working in this section. This is the main use of protective shield. ಇದು ಆ ರೇಡಿಯೇಷನ್ಸ್ಗಳು ಹೊರಗಡೆ ಬಂದು ಆ ಜನಗಳಿಗೆ ಆರೋಗ್ಯ ಸಮಸ್ಯೆ ಆಗದಂತೆ ನೋಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಇರುವಂತಹ ಒಂದು ರಕ್ಷಾ ಕವಚ, ಅದನ್ನೇ ಪ್ರೊಟೆಕ್ಟಿವ್ ಶೀಲ್ಡ್ ಅಂತ ಕರಿತೀವಿ. ದಪ್ಪನೆಯ ಸಿಮೆಂಟ್ ದಪ್ಪನೆಯ ಒಂದು ಇದರಿಂದ ಇದನ್ನು ಮಾಡಿರ್ತಾರೆ. Right? This is about protective shield. So what are the 5 parts of nuclear reactor? First part ಯಾವದಪ್ಪ ಅಂದ್ರೆ fissionable material, ಅಂದ್ರೆ fuel of the nuclear reactor. Second part ಯಾವುದು moderator, ಆ ನ್ಯೂಟ್ರಾನ್ಗಳ ವೇಗವನ್ನು ತಗ್ಗಿಸಲು ನೀವೇನು ಉಪಯೋಗ ಮಾಡ್ತೀರಿ ಅವೇ moderator. ಎಕ್ಸಾಂಪಲ್ ಯಾವ ಮಾಡರೇಟರ್ಸ್ಗೆ ಗ್ರಾಫೈಟು, ಹೆವಿ ವಾಟರ್ ಅಂತ ಬರೆದಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಕಂಟ್ರೋಲ್ ರಾಡ್ಸ್, ಅವು ಒಂದು ಏನು ಕಂಟ್ರೋಲ್ ರಾಡ್ಸ್ ಅಂದರೆ ಆ ಒಂದು ಫಿಸನ್ ರಿಯಾಕ್ಷನ್ ಕಂಟ್ರೋಲ್ಡ್ ಮ್ಯಾನರ್ ಆಗಬೇಕು. ಫಿಸನ್ ಚೈನ್ ರಿಯಾಕ್ಷನ್ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಕಂಟ್ರೋಲ್ಡ್ ಮ್ಯಾನರ್ ಆಗಬೇಕು ಅಂದರೆ ಯು ಶುಡ್ ಯೂಸ್ ಕಂಟ್ರೋಲ್ ರಾಡ್ಸ್. ಕಂಟ್ರೋಲ್ ರಾಡ್ಸ್ ಏನು ಮಾಡ್ತಾವ, ದೇ ಅಬ್ಸಾರ್ಬ್ ಎಕ್ಸೆಸ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಆ್ಯಂಡ್ ಅಲೋ ಓನ್ಲಿ 1 ನ್ಯೂಟ್ರಾನ್ ಫಾರ್ ಕಾಸಿಂಗ್ ಫಿಸನ್ ಪ್ರೋಸೆಸ್. 3 ನ್ಯೂಟ್ರಾನ್ಸ್ ರಿಲೀಸ್ ಆಗಿದೆ ಅಂತ ತಿಳ್ಕೊಳ್ರಿ. 3ರಲ್ಲಿ 2ಅನ್ನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡಿಕೊಂಡು ಒಂದೇ ಒಂದು ನ್ಯೂಟ್ರಾನ್ನ ಮುಂದೆ ಪ್ರೋಸೆಸ್ಗೆ ಕಳಿಸ್ಕೊಳ್ತಾವ. ಅದನ್ನೇನು ಕರಿತೀವಿ ನಾವು, ಕಂಟ್ರೋಲ್ ರಾಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಎಕ್ಸಾಂಪಲ್ ಯಾವುದು, ಕ್ಯಾಡ್ಮಿಯಂ ಮತ್ತು ಬೋರಾನ್, ಕ್ಯಾಡ್ಮಿಯಂ ಅಂಡ್ ಬೋರಾನ್ ರಾಡ್ಸ್. ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ಹಿಯರ್, ಸಿ ನೆಕ್ಸ್ಟ್ ಯಾವುದು ಎಕ್ಸಾಮ್, ಫೋರ್ತ್ ಒನ್ ಕೂಲೆಂಟ್. ಇಲ್ಲಿ ಹೀಟ್ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಈ ಮೆಟಲ್. ಈ ಹೀಟ್ ನ ರಿಮೂವ್ ಮಾಡೋದು ಯಾವುದು, ಕೂಲಿಂಗ್ ಮೆಟೀರಿಯಲ್, ಅದು ಯಾವುದು, ಕೂಲೆಂಟ್. ಏನಂತ ಕರೀತಾರೆ ಅದನ್ನ, ಕೂಲೆಂಟ್ ಅಂತ ಕರೀತಾರೆ, ಕೂಲೆಂಟ್. Right? So it is the one which removes heat from the core of the reactor. Example ಯಾವುದು, water, CO2 and nitrogen. So ಈ wall ಅಲ್ಲ, outer wall, reactor wall, this is having maximum thickness. ಇದು ದಪ್ಪ, ಬಹಳಷ್ಟು ದಪ್ಪದಲ್ಲಿ ಇದನ್ನ ರೆಡಿ ಮಾಡಿರ್ತಾರೆ. ಕಾಂಕ್ರೀಟ್ ಸಿಮೆಂಟ್ ಇಂದ ಬಹಳಷ್ಟು ದಪ್ಪದಲ್ಲಿ ಇದನ್ನ ಮಾಡಿರ್ತಾರೆ outer wall ನ, just to protect the people from the dangerous radiations which may be emitted in the nuclear reaction or fission process. So to protect the people from the problems of health issues, so here the wall is maintained with maximum thickness, that is called protective shield. Adenu karithi ನಾವು protective shield anta karithi. These are the different parts of nuclear reactor. So name the first reactor of India, Apsara. So idu for what is the nuclear reactor, the concept of nuclear reactor, it was given by the foreign scientist Enrico Fermi. And what is nuclear reactor? A device in which fission is controlled. Fission is carried out in a controlled manner. Fission chain reaction is carried out in controlled manner to get nuclear power. That is called nuclear reactor. So there are 5 parts, right? I hope you understood about nuclear reactor. Say next one. The next type of nuclear reaction is nuclear fission. So now only learned about fission. So now it's time for learning about nuclear fusion. Here fusion means combining. Combining of 2 things. So here what is nuclear fusion? Two smaller nuclei, small nucleus. Here this is small nucleus. Two smaller nucleus, they combine together and give rise to a heavier nucleus. Heavy nucleus plus energy. See, this type of process is called nuclear fusion. What is nuclear fusion? This is the process of combining of 2 lighter nuclei to form a heavy nucleus with the release of large amount of energy is called nuclear fusion. The phenomenon of combining of the phenomenon of combining of two lighter nuclei, combining of two lighter nuclei to form a heavy nucleus, with the release of energy is called this is called nuclear fusion. Yes, the phenomenon of combining of two lighter nuclei to form a heavy nucleus with the release of energy is called nuclear fusion. So this concept it was given by Hans Bethe, scientist named Hans Bethe. So a scientist named Hans Bethe he gave the concept of nuclear fusion. Nuclear fusion ಅಂದ್ರೆ ಎರಡು ಸಣ್ಣ ನ್ಯೂಕ್ಲಿಯೈಗಳು ಸೇರಿ ಒಂದು ದೊಡ್ಡ ನ್ಯೂಕ್ಲಿಯಸ್ ಆಗಿ ಬದಲಾವಣೆ ಹೊಂದೋದನ್ನ ನಾವು ನ್ಯೂಕ್ಲಿಯರ್ ಫ್ಯೂಷನ್ ಅಂತ ಕರೀತೀವಿ. So for example here example of nuclear fusion, example 1h2 plus 1h2. This is say neutron. What are these? Neutron nucleus. This is neutron. So here helium nucleus plus energy. So say neutron plus neutron, when these two nuclei when they combine with one another, they results in the formation of helium isotope. Plus one neutron. Here mass number 2 plus 2 4. Here mass number 3 plus 1 4. So here one atomic number 1 plus 1 2. 2 plus 0 2. Energy. This energy will be equals to up to 17 mega electron. Here the energy released in nuclear fusion process is up to 17 mega electron. Yes, what is nuclear fusion? Nuclear fusion is the phenomenon of combining of two lighter nuclei to form a heavy nucleus with the release of energy, large amount of energy. That is called nuclear fusion. The concept of nuclear fusion it was given by the scientist Hans Bethe. An example is when two nuclei of deuterium combine fuses together, they forms an helium isotope and one neutron plus 17 mega electron volt of energy. Here the main see this type of reactions they are naturally occurring in stars and the sun and stars. See, this is nuclear fusion is occurring in sun and stars. Sun and stars they are giving out energy. By means of nuclear fusion. So here one thing you must understand. Here this is a neutron. So these are the isotopes of hydrogen. So here they are combining. Hydrogen means here positive. Here neutron positively charged. Neutron and neutron these are positively charged. So see here for combining two positively charged nuclei together, you must have see here there exists a repulsive force between hydrogen nucleus and this deuterium nucleus and this nucleus. So there exists a strong force of repulsion between two positively charged particles. So neutron positively charged particle ಅದ ಇವೆರಡರ ನಡುವೆ ಏನಿರ್ತದ ಚಾರ್ಜ್ ಏನಂದ್ರೆ ಚಾರ್ಜ್ ಪ್ಲಸ್ ಇರೋದ್ರಿಂದಾಗಿ ಇವುಗಳ ನಡುವೆ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಇರುತ್ತೆ. ಆ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ನ ಓವರ್ಕಮ್ ಮಾಡಬೇಕು. ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಏನು ಮಾಡಬೇಕು, ಫಸ್ಟ್ ಡಿಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಆ ಡಿಕ್ರೀಸ್ ಮಾಡೋದು ಹೇಗೆ ಅಂದ್ರೆ there must be high temperature for the stars or the sun in which this process is carried out. So that temperature is about 10 to the power of 5 to 10 to the power of 9 Kelvin. Temperature ಯಾವ ರೇಂಜ್ ಅಲ್ಲಿ ಇರಬೇಕಂದ್ರೆ 10 to the power of 5 to 10 to the power of 9 Kelvin ಇಷ್ಟು ಒಂದು ರೇಂಜ್ ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ನ ಮೇಂಟೈನ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ this large temperature it overcomes the force of repulsion present between these two positively charged nuclei. So what is the charge of the nucleus? Positive. So here one neutron nucleus is combining with another neutron nucleus. So what is happening here? When they are combined means first you must overcome the force of repulsion. So the force of repulsion here. Repulsive force is the force of repulsion. Force of repulsion. Give another example. First example, second example. 1 plus 1H1. Here two protons are combining together to form an isotope of hydrogen, neutron. See, neutron plus positron plus energy. See, this is a proton. Two protons are combined together. Proton. This is neutron. This is positron. Here what is happening here? Two protons are combined together. To give rise to neutron. So here protons are positively charged particles. So for combining of two protons, what is the problem? There exists a force of repulsion between the two nuclei. ಆ ಎರಡು ಪ್ರೋಟಾನ್ ನ್ಯೂಕ್ಲಿಯೈ ನಡುವೆ ಒಂದು ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಅದ. ಆ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಓವರ್ಕಮ್ ಮಾಡೋದಕ್ಕೆ ಏನು ಬೇಕು? ಯು ನೀಡ್ ಎ ಟೆಂಪರೇಚರ್ ಆಫ್ 10 to the power of ಎಸ್ಟಿಮೇಟ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ಸ್ಟಾರ್ ಆರ್ ಟೆಂಪರೇಚರ್ ಆಫ್ ದ ರೂಮ್ must be equals to 10 to the power of 5 to 10 to the power of 9 Kelvin. So see, on the earth or in a laboratory, this much of temperature is not it is practically not possible. It is to get the temperature of 10 to the power of 5 to 10 to the power of 9, it is not possible. Now up to 40-45 ತರ temperature ನ ಅಚೀವ್ ಮಾಡಬಹುದು ರೂಮ್ ನಲ್ಲಿ. ಬಟ್ ನೀವು 100 ತನಕ ಮಾಡಬಹುದು ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ 100 ತರ ಮಾಡಿದ್ರೆ we cannot survive in this temperature. Our lab temperature ನಾವು ಇರಕ್ಕಾಗಲ್ಲ. ಸೊ 40-50 ಗೆ ನಮಗೆ ಏನೇನೋ ಆಗ್ಬಿಡುತ್ತೆ. 40 ಕೆಲ್ವಿನ್ 50 ಕೆಲ್ವಿನ್ ಗೆ ಏನೇನೋ ಆಗ್ಬಿಡ್ತವೆ, ಹೆಲ್ತ್ ಇಶ್ಯೂಸ್ ಬರ್ತಾವೆ. ಸೊ ಇಲ್ಲಿ ನೀವು ಈ ತರ ಟೆಂಪರೇಚರ್ ನ ಮೇಂಟೈನ್ ಮಾಡಿದ್ರೆ ಮಾತ್ರ ಯು ಕ್ಯಾನ್ achieve nuclear fusion process in a laboratory. So this is not commonly, see, it is not possible to carry out nuclear fusion on the earth, but all the stars and sun, they are giving the energy by the phenomenon of fusion, nuclear fusion. How much temperature is required? 10 to the power of 5 to 10 to the power of 9 Kelvin. 1 lakh Kelvin ಇರಬೇಕು. ನಮಗೆ ಎಷ್ಟಿದೆ ಟೆಂಪರೇಚರ್ ಈಗ? ಸಿ ರೂಮ್ ಟೆಂಪರೇಚರ್ 27 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅದ ಪ್ಲಸ್ 273. ಸೊ ಎಷ್ಟಾಯ್ತು? 300 ಕೆಲ್ವಿನ್ ಅದು. ಈಗ ಸದ್ಯ ಈಗಿರುವಂತ ಒಂದು ಉಷ್ಣತೆ 300 ಕೆಲ್ವಿನ್ ಅದು. 300 ಕೆಲ್ವಿನ್ ಅಲ್ಲ, 300 ಕೆಲ್ವಿನ್ ಅಂದ್ರೆ ಎಷ್ಟಾಗ್ತಾ ಇದೆ? 10 to the power of 3 into 10 to the power of 2 ಕೆಲ್ವಿನ್. 10 to the power of 2 ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಇದೆ. ಬಟ್ 10 to the power of 5 ಕೆಲ್ವಿನ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಅದು 3 ಪಟ್ಟು. ಅದು 3 ಪಟ್ಟು ಅಂದ್ರೆ ಪಾಸಿಬಲ್ ಇಲ್ಲ ಅರ್ಥ ಮೇಲೆ. So this is the problem. Why? You see, if you are able to if you are able to generate this type of temperature, then you can easily obtain this fusion process wherever you want, in a laboratory or in a house. So ಇನ್ನು ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಇದು. ಈ ಪ್ರೋಸೆಸ್ ಯಾಕೆ ನಾವು ಮಾಡಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ, ಫಸ್ಟ್ ಟೆಂಪರೇಚರ್ ಆಫ್ 10 to the power of 5 to 10 to the power of 9 Kelvin is not possible on the earth. This is the first problem. Second problem is to maintain ಮಾಡಿದ್ರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಫ್ಯೂಯಲ್ ಏನು ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ ನೀವು, ಪ್ರೋಟಾನ್ಗಳು. ಈ ಪ್ರೋಟಾನ್ಗಳು ಏನಾಗ್ತಾವ? ದೇ ಬಿಕಮ್ ಪ್ಲಾಸ್ಮಾ ಸ್ಟೇಟ್. ದೇ ಒಬ್ಟೈನ್ ಪ್ಲಾಸ್ಮಾ ಸ್ಟೇಟ್. ಪ್ಲಾಸ್ಮಾ ಸ್ಟೇಟ್ ಅಂದ್ರೆ ಏನು ಕರೀತಾರೆ ಅಂದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಸ್ಟೇಟ್. ಕುದಿಯುವಂತ ಒಂದು ಸ್ಥಿತಿಯಲ್ಲಿ ಇರ್ತಾವೆ. ಕುದಿಯುವ ಸ್ಥಿತಿಯಲ್ಲಿ ಇರ್ತಾವೆ. they are of a plasma state. So if this much of temperature is maintained in a room, then the fuels which are used in the fusion process, they are of plasma state. Then there is no bottle or there is no any instrument to handle the plasma state. ಆ ಒಂದು ಕುದಿತಾ ಇರುವಂತಹ ಪ್ರೋಟಾನ್ಗಳನ್ನ ಹಿಡಿದಿಡೋದಕ್ಕೆ ಏನ್ ಬೇಕು ನಮಗೆ, ಆ ಥರ ಯಾವ ವೆಸಲ್ಸ್ಗಳು ಇಲ್ಲ, ಬಾಟಲ್ಸ್ಗಳು ಇಲ್ಲ. ಈ ಎರಡು ಪ್ರಾಬ್ಲಮ್ನಿಂದಾಗಿ ನಾವು ಈ ಒಂದು ಫ್ಯೂಸನ್ನ ಅರ್ತ್ ಮೇಲೆ ಮಾಡೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ ಭೂಮಿ. ಬಟ್ ಫಿಸನ್ ಆಟಮ್ ಬಾಂಬ್ ಮೇಲೆ ಬಾಂಬ್ ಅಟ್ಯಾಕ್ ಮಾಡ್ತಾರಲ್ಲ, ಅದೆಲ್ಲ ಫಿಸನ್ ಪ್ರೋಸೆಸ್. ಫ್ಯೂಸನ್ ಪ್ರೋಸೆಸ್ ಯಾಕೆ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ಸ್, ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಟೆಂಪರೇಚರ್ ಬರುತ್ತೆ. Temperature is the first problem. High temperature is required. Second problem, handling of boiling protons, boiling fuels. ಇಷ್ಟು ಟೆಂಪರೇಚರ್ ಏನಾದರೂ ಮೇಂಟೈನ್ ಮಾಡಿದ್ವಿ ಅಂದರೆ ಈ ಒಂದು ಫ್ಯೂಯಲ್ ಏನಾಗ್ತದೆ, ಬಾಯ್ಲ್ಡ್ ಸ್ಟೇಟ್ ಹೋಗ್ತದೆ, ಮೆಲ್ಟ್ ಆಗ್ತಿರೋ ಸ್ಟೇಟ್ ಹೋಗ್ತದೆ. ಆ ಪ್ಲಾಸ್ಮಾ ಸ್ಟೇಟ್ ಅದನ್ನು ಹ್ಯಾಂಡಲ್ ಮಾಡೋದಕ್ಕೆ ಯಾವುದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಗಳು ನಮ್ಮಲ್ಲಿ ಸದ್ಯದ ಮಟ್ಟಿಗೆ ಯಾವುದು ಇಲ್ಲಿ ಲಭ್ಯವಿಲ್ಲ, ಅವೈಲೇಬಲ್ ಇಲ್ಲ. ಆ ಥರ ಇತ್ತು ಅಂದರೆ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ಮೋರ್ ಅನ್ಲಿಮಿಟೆಡ್ ಪವರ್. ಇದರಲ್ಲಿ ಅನ್ಲಿಮಿಟೆಡ್ ಜಸ್ಟ್ ನಾವು 17 ಅಂತ ಹೇಳಿದಾಗ 17 ಜಸ್ಟ್ ಒಂದು ಆಟಮ್ ಇದೆ. ಬಟ್ ಕಂಪೇರ್ಡ್ ಟು ಫಿಸನ್ ಪ್ರೋಸೆಸ್, ಫ್ಯೂಸನ್ ಗಿವ್ಸ್ more amount of electrical power, because ಈ ಹೈಡ್ರೋಜನ್ ಇವೆಲ್ಲ ಏನದವ ಲೆಸ್ ಎಕ್ಸ್ಪೆನ್ಸಿವ್. ಇದು ಯುರೇನಿಯಂ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಹೈಡ್ರೋಜನ್ ಇವೆಲ್ಲ ತಗೊಳ್ಳೋದು ಲೆಸ್ ಎಕ್ಸ್ಪೆನ್ಸಿವ್. ನಾವು ಈಸಿಯಾಗಿ ತಗೋಬಹುದು, ಈಸಿಯಾಗಿ ನಮಗೆ ಕಡಿಮೆ ಕಾಸ್ಟ್ ನಲ್ಲಿ ಅವೈಲೇಬಲ್ ಅದಾವೆ ಯಾವ ಸ್ಟಾರ್ಟಿಂಗ್ ಮೆಟೀರಿಯಲ್ಸ್. ಬಟ್ ಯುರೇನಿಯಂ ಕಾಸ್ಟ್ ಭಾಳ ಅದ, ಯುರೇನಿಯಂ ಅವು ಎಕ್ಸ್ಪೆನ್ಸಿವ್ ಅದಾವ, ರೈಟ್. ಸೂರ್ಯನಲ್ಲಿ sun has these fuels. See, what is the fuel in sun? Hydrogen is present in maximum extent. It is the hydrogen of the sun is up to another 5 into 10 to the power of 7 years. ಎಷ್ಟು ತರ ಇದೆ ಫ್ಯೂಯಲ್ ಅಂದ್ರೆ ಸೂರ್ಯನಲ್ಲಿ ಫ್ಯೂಯಲ್ ಎಷ್ಟು ವರ್ಷದಿದೆ ಅಂತ ಏನಾದರೂ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ 5 into 10 to the power of 7 years ಅನ್ನೋದು. After this much of years, this many years, sun will become red giant. ಎಲ್ಲ ಸೂರ್ಯನಲ್ಲಿ ಇರುವ ಎಲ್ಲ ಫ್ಯೂಯಲ್ ಹೈಡ್ರೋಜನ್ ಮುಗಿದೋಗ್ಬಿಡ್ತದೆ ಇಷ್ಟು ವರ್ಷಗಳಾದ. ಸೂರ್ಯ ಕೆಂಪು ದೈತ್ಯ ಆಗಿ ಬದಲಾಗ್ತಾನ, ಭೂಮಿಯ ನಾಶ ಆಗ್ತದೆ. ಎಷ್ಟು ವರ್ಷ ನಾವ್ಯಾರಲ್ಲ, ನಾವಿರಲ್ಲ, ನೀನಿರಲ್ಲ, ನಿನ್ನ ಮೊಮ್ಮಕ್ಕಳು ಇರಲ್ಲ, ಭಾಳ ವರ್ಷಗಳು 500 billion years ಅಂತ ಆಗ್ತದೆ. 5 billion years ಇನ್ನೂ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇದು ಇಷ್ಟು 10 to the power of 7 years. ಸೊ ಅಲ್ಲಿ ನಮ್ಮ ಸೂರ್ಯನಲ್ಲಿ ಇದೇ ಪ್ರೋಸೆಸ್ ನಡೀತಾ ಇರ್ತದ, ದಿನ ಬೆಳಗಾಗ್ತಾ ಇರ್ತದ, ನ್ಯಾಚುರಲ್ ಪ್ರೋಸೆಸ್ಗಳು ಆಗ್ತಾ ಇರ್ತವೆ, ರೈಟ್. ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ನ್ಯೂಕ್ಲಿಯರ್ ಫ್ಯೂಸನ್. ಇಟ್ ಈಸ್ ನಾಟ್ ಎ ಚೈನ್ ಪ್ರೋಸೆಸ್. ಇದು ಚೈನ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲ, ಇದು ಕಂಟ್ರೋಲ್ಡ್ ಮ್ಯಾನರ್ ನಾಗಿಲ್ಲ. ದಿಸ್ ಕೆನಾಟ್ ಬಿ ಕ್ಯಾರಿಡ್ ಔಟ್ ಇನ್ ಕಂಟ್ರೋಲ್ಡ್ ಮ್ಯಾನರ್. ಇದು ಚೈನ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲ, ಕಂಟ್ರೋಲ್ಡ್ ಮ್ಯಾನರ್ ನಾಗಿಲ್ಲ. ನ್ಯಾಚುರಲ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಇದು ನಡೆಯಲ್ಲ. ಇದು ಟೆಂಪರೇಚರ್ ಇಷ್ಟು ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಬೇಕು, ರೈಟ್. ಮತ್ತು ಇದರಲ್ಲಿ ಯಾವುದೇ ನ್ಯೂಕ್ಲಿಯರ್ ವೇಸ್ಟ್ ರೇಡಿಯೇಷನ್ಸ್ ಇಲ್ಲ. ಸಿ ದಿಸ್ ಪ್ರೋಸೆಸ್ ಈಸ್ ನಾಟ್ ಗಿವಿಂಗ್ ಎನಿ ಅಮೌಂಟ್ ಆಫ್ ನ್ಯೂಕ್ಲಿಯರ್ ವೇಸ್ಟ್ ಆಸ್ ಇಟ್ ಈಸ್ ಕಾಮನ್ಲಿ ಗಿವನ್ ಬೈ ಫಿಸನ್ ಪ್ರೋಸೆಸ್. ಇದು ಯಾವುದೇ ನ್ಯೂಕ್ಲಿಯರ್ ವೇಸ್ಟ್ಗಳನ್ನು ಕೊಡಲ್ಲ. ಇದು ಬಹಳ ಬೆಸ್ಟ್ ಅದ. ಆ್ಯಂಡ್ ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಎ ಹೈಯರ್ ನ್ಯೂಕ್ಲಿಯರ್ ಪವರ್ ಕಂಪೇರ್ಡ್ ಟು ಫಿಸನ್ ಪ್ರೋಸೆಸ್. See, now we shall learn differences between nuclear fission and nuclear fusion. So here, see, what is the first difference? First difference is the definition. What is fission process? It is the breaking or splitting up of a heavy nucleus into two smaller nuclei. It is the splitting up of or breaking of a heavy nucleus into two smaller sized nuclei. Fusion, reverse process, combining of two smaller nuclei into a heavy nucleus. Combining of two smaller nuclei, ಎರಡು ಸಣ್ಣ ನ್ಯೂಕ್ಲಿಯೈಗಳು ಕಂಬೈನ್ ಆಗಿ ಒಂದು ದೊಡ್ಡ ನ್ಯೂಕ್ಲಿಯಸ್ ನ ಫಾರ್ಮ್ ಮಾಡುವುದು ಫ್ಯೂಸನ್. ಇಲ್ಲಿ ಒಂದು ದೊಡ್ಡ ನ್ಯೂಕ್ಲಿಯಸ್ ಬ್ರೇಕ್ ಆಗಿ ಎರಡು ಸಣ್ಣ ನ್ಯೂಕ್ಲಿಯೈಗಳನ್ನು ಫಾರ್ಮೇಷನ್ ಮಾಡೋದು ಫ್ಯೂಸನ್ ಪ್ರೋಸೆಸ್. ಇದು ಚೈನ್ ಪ್ರೋಸೆಸ್ ಇದು, ಅದು ಚೈನ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲ. ಇದನ್ನ ಕಂಟ್ರೋಲ್ಡ್ ಮಾಡಬಹುದು. ಫಿಸನ್ ಅಂದ್ರೆ ಕಂಟ್ರೋಲ್ಡ್ ಅನ್ಕಂಟ್ರೋಲ್ಡ್. ಅದು ಅನ್ಕಂಟ್ರೋಲ್ಡ್ ಯಾವಾಗ ಕಂಟ್ರೋಲ್ ಮಾಡಕ್ ಬರಲ್ಲ ಫ್ಯೂಸನ್. ಫ್ಯೂಸನ್ ಸ್ಟಾರ್ಸ್ ಅಲ್ಲೇ ಆಗುತ್ತೆ, ಸ್ಟಾರ್ಸ್ ಅಲ್ಲಿ ಕಂಟ್ರೋಲ್ ಮಾಡಕ್ ಬರಲ್ಲ. ಇಟ್ ಕೆನಾಟ್ ಬಿ ಕಂಟ್ರೋಲ್. ಹೈ ಟೆಂಪರೇಚರ್ ಇಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್. ಹೈ ಟೆಂಪರೇಚರ್ ಬೇಕಾಗಿಲ್ಲ ಯಾವುದಕ್ಕೆ? ಫಿಸನ್ಗೆ. ನಾರ್ಮಲ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಕೂಡ ಈ ಫಿಸನ್ ಪ್ರೋಸೆಸ್ ರಿಯಾಕ್ಟರ್ಗಳು ಕೆಲಸ ಮಾಡಬಹುದು. ಬಟ್ ಅದು ಹೈ ಟೆಂಪರೇಚರ್ ಬೇಕೇ ಬೇಕು. ಹೈ ಟೆಂಪರೇಚರ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. ನ್ಯೂಕ್ಲಿಯರ್ ವೇಸ್ಟ್ ಈಸ್ ಲೆಫ್ಟ್. ನ್ಯೂಕ್ಲಿಯರ್ ರೇಡಿಯೇಷನ್ಸ್ ಅಥವಾ ವೇಸ್ಟ್ ಮೆಟೀರಿಯಲ್ಸ್ ಉಳಿಯುತ್ತೆ ಯಾವುದರಲ್ಲಿ? ಫಿಸನ್ ಪ್ರೋಸೆಸ್ ನಲ್ಲಿ. ಹಿಯರ್ ನ್ಯೂಕ್ಲಿಯರ್ ವೇಸ್ಟ್ ಈಸ್ ನಾಟ್ ಲೆಫ್ಟ್. Nuclear radiations or nuclear waste materials are not found in fusion process. They are not left in the fusion process. So here fusion process artificial. ನಾವೇ ಮಾಡಬೇಕು. ಮನುಷ್ಯ ರಿಯಾಕ್ಟರ್ಗಳಿಂದ ಮನುಷ್ಯನೇ ರೆಡಿ ಮಾಡಬೇಕು. ರಿಯಾಕ್ಟರ್ ಆಯಿತು, ಆಟಮ್ ಬಾಂಬ್ ಆಯಿತು, ನಮ್ಮಿಂದ ರೆಡಿ ಆದಂತಹ ಒಂದು ಕ್ರಿಯೆ ಆರ್ಟಿಫಿಷಿಯಲ್ ಪ್ರೋಸೆಸ್. ಬಟ್ ಸ್ಟಾರ್ಸ್ ಎಲ್ಲ ಆಗೋದು ನ್ಯಾಚುರಲ್ ಪ್ರೋಸೆಸ್. ಯಾವುದು? ನ್ಯೂಕ್ಲಿಯರ್ ಫ್ಯೂಸನ್, ನ್ಯಾಚುರಲ್ ಪ್ರೋಸೆಸ್. ಎನರ್ಜಿ ಪರ್ ರಿಯಾಕ್ಷನ್, ಒಂದು ರಿಯಾಕ್ಷನ್ ಕಂಪ್ಲೀಟ್ ಆದಾಗ ಅದರ ಎನರ್ಜಿ ಮ್ಯಾಕ್ಸಿಮಮ್ 200 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್. ಒಂದು ರಿಯಾಕ್ಷನ್ ಎಷ್ಟು ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗುತ್ತೆ ಫಿಸನ್ ಅಲ್ಲಿ? 200 ಮ್ಯಾಕ್ಸಿಮಮ್. ಎನರ್ಜಿ ಪರ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ಮಿನಿಮಮ್ 70 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್. So energy per reaction is maximum 200 mega electron volt. There is 17 mega electron. So these are the sum of the differences between nuclear fission and fusion. First definition of nucleus. Second, chain process idu adu chain process alla. Third, idನ್ನ ಕಂಟ್ರೋಲ್ ಮಾಡಬಹುದು, ಅದನ್ನ ಕಂಟ್ರೋಲ್ ಮಾಡಕ್ಕಾಗಲ್ಲ. Fourth, ಇದಕ್ಕೆ ಯಾವುದೇ ಹೈ ಟೆಂಪರೇಚರ್ ಬೇಕಾಗಿಲ್ಲ ಫಿಸನ್ ಗೆ, ಅದಕ್ಕೆ ಹೈ ಟೆಂಪರೇಚರ್ ಬೇಕು. Fifth, ನ್ಯೂಕ್ಲಿಯರ್ ವೇಸ್ಟ್ ಇದರಲ್ಲಿ ಉಳಿಯುತ್ತೆ, ಅದರಲ್ಲಿ ಉಳಿಯಲ್ಲ. Sixth, ಇದು ಆರ್ಟಿಫಿಷಿಯಲ್ ಪ್ರೋಸೆಸ್, ಮನುಷ್ಯನೇ ಮಾಡಬೇಕು. ಅದು ನ್ಯಾಚುರಲ್ ಪ್ರೋಸೆಸ್, ಅದಷ್ಟೇ ತಾನೇ ಆಗುತ್ತೆ. ಸ್ಟಾರ್ಗಳನ್ನು ಎನರ್ಜಿ ಒಂದು ರಿಯಾಕ್ಷನ್ ಅಂತಂದ್ರೆ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗಿದ್ದು 200 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಇರುತ್ತೆ. ಇದು ಒಂದು ರಿಯಾಕ್ಷನ್ ಮುಗಿದ್ರೆ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗಿದ್ದು 70 ಮೆಗಾ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಷ್ಟು ಇರುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಸಮ್ ಆಫ್ ದ ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಸನ್ ಅಂಡ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫ್ಯೂಸನ್, ರೈಟ್? So this completes your nucleus chapter. Nucleus chapter gets completed with this concept. So tomorrow I am starting a new chapter called semiconductor electronics, the last unit of your second year syllabus. That is the last unit of your second year syllabus. So keep watching all the videos of your syllabus and try to read and try to practice along with the classes, right? Have a nice day.